Hello, this is video 77. It's called Rise or Sink. In this video, we're going to see what happens to an object when we place it in water. Is it going to sink to the bottom or rise to the surface? And this has to do with two things. It has to do with the buoyant force acting on the object, and it also has to do with the density of the object. And you can look at either one to figure out what's going to happen to that object. First, let's take a look at the forces on the object. When your object is placed in water, it's going to have a buoyant force upward and a weight going down. If the buoyant force is greater than the weight, that means that the net force is upward. So, as you can see in this picture, that means that the object is going to rise. So an object rises when the weight is smaller than the buoyant force. The buoyant force is bigger, the net force is upward, it's going to rise. And vice versa. An object is going to sink when the weight is greater than the buoyant force, as in this picture. The weight, the arrow is bigger, that means the net force is downward. That means the acceleration is downward. So, well, how do we know if the buoyant force is greater or smaller than the weight? Well, remember that the buoyant force has to do with what is the weight of the fluid displaced. So what's the weight of this liquid that is pushed out of the way by this object? So that means that if the object weighs more than the weight of that liquid that it pushes out of the way, that means the object is going to sink, as in this piece of iron or lead here. If the object weighs less than the amount of fluid that is displaced, then that means that the object will rise. So you can see that this has to do with the density of the object. And what I like to do is I like to just show you this. It's a good exercise. It's not going to take long. Let's just replace what we know for the weight of the object and the buoyant force. We know that the weight of the object is equal to the mass of the object times g. And the buoyant force is equal to rho vg for the fluid. Rho of fluid, v fluid, and g. And then we make our usual substitution with mass, how it's related to density times volume. Remember that density is mass over volume. That means that mass equals density times volume. So we can replace the mass of the object by the density of the object times the volume of the object. Notice in this equation here that the g's cancel out. And I should say inequality, not equation, since it's smaller than this over here on the right-hand side. So we're left with the density of the object times the volume of the object is less than the density of the fluid times the volume of the fluid displaced. One last thing, this object is completely submerged, and in that case we say that VFL equals V of object. The object pushes out the same amount of liquid as its volume. So if these two are the same, they cancel out. So this means that when the density of the object is less than the density of the liquid, that means that the object will rise. We can do the same exact thing for the sinking object. The only difference is that the sign changes. Since over here, the weight was smaller than the buoyant force when it rose, when it sinks, the weight is greater than the buoyant force. So all we have to do is say, well, the density of the object is going to be greater than the density of the fluid. We just rewrite all of this with the sign pointing in the opposite direction. So to summarize, an object is going to rise when the density of the object is less than the density of the liquid. An object is going to sink when the density of the object is greater than the density of the liquid. And this is also related to the amount of buoyant force. When the density of the object is less than that of the liquid, that means that its weight is less than the buoyant force. And vice versa. When it sinks, its weight is more than the buoyant force.